Hello everyone. Now consider next example, that is 69th example. These are homeworks to you. The integration, we are just learn the Laplace transform of the integration. Here are some examples, homeworks examples for you. The first one is 0 to t integration 0 to t cos at minus cos at upon t. We have to find out Laplace of all these things. Okay, this is the question. Find Laplace of, this is but obvious the our original question, following functions or integrations. Okay, this one, these are three examples for homework. This is also for homework, but in this example the integrand is u into e raised to minus u sine 4u. Generally we have seen that integrand is in terms of t, okay, our original variable t, but here in this example or in any example it can be given in terms of other variable also. Okay, this is a dummy variable. We know that integration of like this, for example, integration of x dx and integration of t dt, suppose for from certain limit 1 to 2, this is also 1 to 2, these are the same integration, these are the equal integration, right? Because just the x and t are just dummy variables. If we interchange or change all the variable by another variable, the value of integration doesn't change. Okay, that's why it is called dummy variable. Here also in this integration u is a dummy variable. You have to first, this I have given hint also, for our convenience, just first step you have to replace u by t everywhere. Just replace u on the first step. Just in the solution itself write down the first step as replace u by t, or u replace u is equal to t everywhere. What will be our example then? 0 to t t e raised to minus t sine 4t dt. Okay, then you can solve this. Okay, these are the three homework examples based on our Laplace of integration point. Okay, now consider the next example. That example is we have to find out Laplace transform of this function. What is this function? You have to first observe. In this function there are two functions. One is cos hyperbolic, which is outside the integration, it is not inside the integration, and it is 0 to t. This is one function, it is the integration. That's why we have to find out first here in inside the integration also cos hyperbolic is there, and outside it is in terms of u. Obviously we have to first replace u by t here also. Then we have to put cos hyperbolic value, that is formula for cos hyperbolic t, outside, which is present outside the integration, not inside the integration, because it is not necessary to find Laplace inside integration. Cos is not necessarily we have to change, it's not necessary, but outside the integration we have to find out this, right? Laplace transform of this. This is our question. But what is the Laplace inside Laplace of the bracket in contains two functions. One is integration. This is but obvious our original example which we are learning, and this is cos hyperbolic t. Okay, instead of cos they can ask for sine also, sine hyperbolic also. The first step you have to replace this cos hyperbolic or put the formula for cos hyperbolic t here first, and in integration also it but obvious, just replace u by t dummy variable. That is our first step. That is here cos hyperbolic t is equal to e raised to t plus e raised to minus t upon 2. This is a formula for cos hyperbolic. And if it is asked for sine hyperbolic, you know, instead of for sine there is only one change, but middle sign is minus only. Okay, whatever the angle here you have to take indice here. Okay, and in this integration you have to just replace u by t. Then above integration becomes, or above question becomes Laplace as it is e raised to t. This is the, you can put bracket or it is not necessary. E raised to t plus e raised to minus t. This is cos hyper upon 2. It is a cos hyperbolic value. This integration, I just replace u by t here, and take half constant anywhere you can take outside. First take constant outside here. This bracket remains in the inside of the bracket, e raised to t plus e raised to minus t into integration. Replace everywhere u by t here. Okay, now just multiply or solve this bracket. Means you have to take integration inside this bracket. What will what it becomes? Half take outside of the whole term, Laplace as it is. Okay, e raised to t into this integration plus e raised to minus t into this integration. Okay, now what we have to do? We have to take Laplace of these two. We have to solve this separately. Okay, now observe these two. The only difference between these two is the exponential term. Okay, we have to find out Laplace of this exponential into this. What that means? We have to find out first. We have to use exponential property here. For exponential property, we have to find out the Laplace of this integration first. This integration shape. That's why we have to just calculate once only. Okay. Now for in this integration, we know the main basic formula is cos hyperbolic t. Okay. Therefore, first find out let f of t. This will be our original function. From that we have to start taking Laplaces. Okay. Now first let f of t is equal to cos hyperbolic t. Take Laplace of f of t, we get s upon this is hyperbolic function, and hyperbolic function Laplace start from cos. It is cos there, that's why numerator is s upon s square. For hyperbolic function denominator contains minus sign. Okay, and this is 1. 1 square is 1. Call it as phi of s because we are going to use exponential property here. Okay, what exponential property? We have to write out L of e raised to at ft dt is equal to phi of s. It is opposite of this minus a. In this case it is plus 80. In this case this is minus 80. Okay, write only once. Okay, only single formula. Now here that's why e raised to Laplace of e raised to t cos hyperbolic t is nothing but phi of s minus this number is minus 1. Okay, what is phi of s minus 1? Just replace phi of s in phi of s by s minus 1 everywhere. That's why it becomes numerator s minus 1, denominator s, it's s minus 1 square minus 1 as it is. Okay, now don't solve the denominator. In earlier examples we just solve this denominator because those were final answers, or we have to just simplify. In this case we are going to use so many properties, that's why just keep that as it is. Okay, and this is phi 1, call it as phi 1 because we are again going to use this. First we are just calculated cos hyperbolic t for Laplace, then we apply exponential property here. Now apply integration, Laplace of integration property. Okay, that's why we have to write Laplace of integration 0 to t ft dt is nothing but phi of s upon s. This is the original formula. Okay, what is phi of s? This integration Laplace. Here in this case what is our f of t? This. And what is phi of s? This is phi 1 of s. That's why apply this formula here. What we get? Laplace of integration 0 to t, first one, e raised to t cos hyperbolic t dt, here dt is there, integration everywhere, is equal to, by this formula, phi 1 of s, this is phi 1, this Laplace upon s. Okay, just divide by s is the only simple formula for Laplace of integration. Now just divide this term by s only, rest of the terms as it is. This we just calculated Laplace of this term. Okay, now we have to again multiply by exponential is there, that's why we have to again use exponential property here. That's why we have to call it as phi 2 of s, this Laplace as phi 2 of s. Now apply again exponential property here. What we get? Laplace of this now e raised to t into this integration is equal to just phi 2 of s, this plus 1 minus 1, opposite of this, using this star by star. Okay, here. Now replace what is phi 2 of s minus 1, just replace s by s minus 1 here in this example, in this term. We get here s minus 1, rest of the terms as it is minus 1. Here again put the brackets, s minus 1, here s minus 1, minus 1 as it is, again square as it is, minus 1 as it is. Okay, this we have just calculated this term. Okay, that Laplace over now, that's why we have to just simplify. This will be our last term we are just going to add this 2. Okay, that's why simplify this. This is s minus 1 minus 1, s minus 2. This is s minus 1 as it is, s minus 2 here, square minus 1. Again expand this square, s minus 2 into s minus 1, s square minus 2 into s, that is 4s, plus 4 minus 1, that is plus 3. Okay, if you observe this this factor, we can factorize this term, that is s minus 1, s minus 3. Just factorize this. Okay, 3 into 1. Okay, and minus 3 and minus 1. Is that okay? Now this is s minus 1 as it is, s minus 2. This is factorized, s minus 1, s minus 3. Okay, this is a square, both brackets are same, therefore final simplification of this term is, this Laplace is s minus 2 into s minus 1 bracket square, s minus 3. This way just calculate Laplace of this term. Okay, in our original equation, in our original formula. Now again this term is remaining here. Okay, this also Laplace is there. That's why, what is the difference between this and this term? Just here plus 1 instead of minus 1 is there. That's why in already we calculate this Laplace. This is phi 2 of s. For this just replace phi 2 of s minus 1 instead of that phi 2 of s plus 1 is there only. That is the only difference between these two. That's why e raised to, we can directly write it as e Laplace of this e raised to minus t, and this integration is equal to phi 2 of s plus 1. Instead of s minus 1, everywhere replace s plus 1. This is the answer, s plus 1 minus 1. This is s plus 1. This is s plus 1 minus 1 square minus 1. Simplify this, what we get? S only, here s plus 1, and this is s square minus 1. Okay, this is one answer, this is other answer. Now just put these two value in our original example. What we get? Therefore from equation number 1, we call it as equation number 1, original example, Laplace of this our original example is equal to half into first answer plus second answer. Okay, these are the most complicated terms, that's why just don't simplify further, just keep that as it is. This is the biggest lengthy example of Laplace. Okay, instead of cos hyperbolic they can ask for sin hyperbolic also. Okay, for sin hyperbolic just replace plus by minus sign and the respective angle. Now these are two homeworks for you. Here e raised to minus 3t, exponential property again, integration sin 3t upon t dt, and this one integration. The question is same, find Laplace transform of this. Okay, now consider, these are two homeworks, this is also homework. Now let us consider next example. Fine, this is the one theoretical example. They can ask for they can ask separately. This is a new question. Find Laplace transform of error function. This is the only statement of the question. Okay, that means you have to know what is the definition of error function, then you have to calculate how to find out Laplace transform of error function. You have to mug up this example. Okay, mug up this at least definition. Now let us see what is the definition of error function and how to calculate Laplace of that. Let us error function can be defined as, this is the definition. Error function, that is ERF small root t, error function of root t is equal to 2 upon root pi integration 0 to root t e raised to minus x square dx. This is the main definition of error function of root t. This is the only root t is itself is there. Okay, now we have to calculate Laplace. Before that, how can we calculate Laplace? Using earlier methods only. Okay, in this chapter what we have learned, exponential property, division by t property. Okay, definition of and a definition of Laplace and other things also, and using that only you have to search all this. Just observe this integration. This constant doesn't matter, constant we can take it outside from the Laplace. We have to just concentrate on this integration. In this integration e raised to minus x square is there, which is not calculated, which we can't calculate by Laplace, we because x square is there. Okay, it is not allowed in Laplace. What is our original formula for Laplace? There are only 7 formulas where e raised to is there, t raised to is there, sine cos is there, sine hyperbolic and cos hyperbolics. Apart from that, we have to use formulas only. That's why first we have to simplify this integration into simple terms where we can apply some rules of Laplace. Okay, now we have to just we have problem for this x square. That's why the only first step for simplifying this integration is we have to replace, or we have to put substitution. We have to put x square is equal to this term, x square is equal to another variable t. Okay, just mug up this is a very important step. Okay, now go on simplifying the integration. X square is equal to, put x square is equal to t. That's why taking derivative on both sides, like what we just do in integration theory or examples. 2x dx, 2x into x derivative dx is equal to dt. We want dx only, that's why dx, take 2x on that side, dt upon 2x. Again we have to put in terms of t. Okay, that's why here x is equal to root of t. That's why I put this value here. What we get, dt upon 2 root t. Okay, this is a substitution. Now we have to find out the limits also. Okay, these are the x limits, original limits 0 to root t. We have to find out new limits of t. Put x is equal to 0 here, we get t is equal to 0. Put x is equal to root t here, what we get, root t square cancel, t becomes t. That's why lower limit is 0, upper limit is t of this integration. Now put all these values in our definition. What we get, error function of root t is equal to 2 upon root pi, lower limit is 0, upper limit is t, e raised to minus as it is, x square becomes t, and dx becomes this term, dt upon 2 root t. Okay, now take constant outside, or this 2 gets cancelled, 1 upon root pi as it is, integration 0 to t, e raised to minus t, and take t on in the numerator. Okay, t raised to, this is half, in the numerator it becomes minus half dt. Okay, this is the most simplified form of this. Now we can familiar with this e raised to and t, all these things. Now taking Laplace on both sides. What is our equation? Find out the Laplace. That's why next step, take Laplace on both sides of the equation. What we get, Laplace of error function of root t is equal to, this is a constant, take it outside, Laplace of this integration. Call this as 1. Now what we have to find? We have to find this in Laplace. Now observe, what we have to find, Laplace of integration. That's why we have to remember the formula for Laplace transform of integration 0 to t is there, f of t dt. What is the formula? Phi of s upon s. What is phi of s? Laplace of this function. What is this function? This function. That means in next step we have to find out this Laplace. Okay, now observe these two function. What is this two function? Exponential is there. That's why we have to use exponential formula here. That means our original function is t raised to minus half. We have to start from Laplace transform of t raised to minus half, then exponential property, then integration of Laplace formula. Okay, now let f of t, call it as f of t. Let f of t is equal to e raised to minus t into t raised to minus half. We have to find out first Laplace transform of t raised to minus half. By this we know gamma formula, because t raised to n have two formulas. One consists of factorial function, other consists of gamma function, where it depends on the n value here, where indices, if indices is integers, then we can use factorial function. If indices is fraction number, we have to use gamma function. What is that formula? Gamma n plus 1, that is minus half plus 1 upon s raised to same number. Okay, which is equal to minus half plus 1 is half here, both side. We know half value is, gamma half value is root pi. This is our well-known formula or well-known number, constant. Upon s raised to half means root s. Call it as phi of s, because we are going to use exponential property. That's why now write down the exponential property, or you can you have to write your exponential property like this. L of e raised to, now minus is there, that's why minus 80 ft becomes, everywhere in the every formula ft is there, phi of s is there. Accordingly we have to use the suffixes and all these things. It is self understood term. Okay, phi of s plus a, this is our original formula we have to use, going to use here. That's why this is the way. Just first we have calculated Laplace of t raised to minus half. Now multiply by e raised to minus t becomes phi of s plus 1 is there, minus 1, opposite of that plus 1. What is phi of s plus 1? Here replace s by s plus 1 only. That's why the answer for this, root pi is a constant as it is, root of s plus 1. Okay. Now this just we calculated Laplace transform of this integrand this way. Okay. Now we have to apply integration formula here, this one. That's why Laplace transform of integration 0 to t e raised to minus t raised to minus half dt, nothing but by this formula phi of s upon s. What is phi of s? This Laplace. What is this Laplace? We have just calculated as this. That's why it becomes phi of s root pi upon s into root of s plus 1. Okay. Now this is Laplace transform of the integration. Now we have to find out, put this value in our original question. Our original question is this. Only we have to divide by root pi. That's why one Laplace transform of error function of root is nothing but 1 upon root pi of this Laplace. Root pi gets cancelled. That's why Laplace transform of error function is nothing but 1 upon s under root s plus 1. Okay, this is the, you have to mug up this formula, because in so many examples where error function is there, you have to use directly this Laplace sometimes. Okay, that's why you have to know what is error function and its Laplace also. Okay, now consider next special example of Laplace transform of integration. We have to find out, question is same. Okay, find Laplace of this triple integration. The only one example where triple integration is there. It is very easy example. If single integration is there, what is the formula? Just phi of s upon s. Okay, for single integration. For double integration, triple integration, whatever the number of integrations are there, you have to just repeat the same formula by division by s only. Okay, for one integration, just division by s. For second integration, division by s square, or simple, yeah, division by s of first integration, and so on. It's like derivative also, derivative only. If you want to calculate the double derivative of one function, what we have to calculate? Single derivative of one function, then derivative of that derivative becomes double derivative. In the same fashion, triple integration means apply the same procedure which we have just applied for single integration. It's a very easy example. Now first, what is the basic function? Cos at. Just we have to start from cos at Laplace. Let f of t is a cos at. Therefore Laplace of f of t is nothing but it is cos. That's why s upon s square plus s square. Call it as phi of s because we are going to use the formula. What is the formula? We know that Laplace transform integration, this inner wall integration first integration, this is second, this one third. Okay, 0 to t ft dt is nothing but phi of s upon s. Therefore Laplace transform of the single integration 0 to t cos at dt becomes 1 upon, just divide by this term by s. Therefore s upon s square plus a square. S gets cancelled. We get 1 upon s square plus a square. Call it as phi of s, phi 1 now, because we are again going to use same integration Laplace formula second time for the second integration. That's why Laplace transform of integration of this integration means it becomes double integration is nothing but this integration's Laplace, that means phi 1 of s upon s is the formula, original formula. That's why just divide this term by s. What we get? 1 upon s and 1 upon s square plus a square as it is. Okay, now call it as phi 2 of s because we are going to use the last third integration formula. That's why Laplace of triple integration of this dt is equal to this phi 2 of s, that is double integration's Laplace upon s. This will be our last answer. Just divide this term by s means here it becomes s square of this 1 upon s square plus s square. You can write it as combinedly s square plus a square. Okay. This is the end of the example. This is one homework for you. Same example, triple integration. We have to find out Laplace transform of triple integration t sin t dt dt dt. That means we have to first find out t sin t's Laplace. How you can find out t sin t Laplace? By multiply by t property, which we have already studied. Okay. This is the homework. Answer for this is given. You just see there. Okay. Now next point, very important point. Till this formula, what we have studied now, how to find out Laplace using different properties and different formulas. Okay, and if using 7 standard Laplaces. Now there are some questions where they are asked to evaluate the integration or find out the value of the integration using Laplace transform. Okay, let us see. These are the only simplest examples. Till date, the all properties I have just finished. Now here onward, just we have to use those properties again and again to learn the new ones. Okay. Now this one, evaluation of integrations. Okay, we know, so we have to start with standard definition of Laplace, that is Laplace of f of t is equal to integration 0 to infinity e raised to minus e s t f t dt. Now observe this in definition. We are going to use this definition only. This Laplace of f of t means this integration. Now think reverse. This integration 0 to infinity e raised to minus e s t f t dt means Laplace of this function. Understood? That's why we have just write integration 0 to infinity e raised to minus s t f t dt means Laplace of f t with parameter s. Okay, what is, we have to just observe or find out the f t function. What is this f t function? The function which is attached to exponential only, and we have to recognize s. Okay. Let us see how we can solve this using examples. Okay, now question changed. Okay, earlier till earlier property, what is the question? Common question, find out the Laplace of. Okay, now here question is changed. You have to read carefully the question first. Evaluate the following integrations. This is the only question. Okay, now consider 77th example first. Integration 0 to infinity e raised to minus 2t sin t dt. Okay, this integration we can solve by earlier any method. This there is one formula also for this solving this integration, but now in this chapter we have to use Laplace only. Okay, to find out the integration. First let us first step of this such type of example is, let's denote that integration as I. Let I is equal to this integration 0 to infinity e raised to minus 2t sin t dt. Call this as number 1. And second step will be your Laplace definition. Now L of f t is equal to integration 0 to infinity e raised to minus e s t f t dt. This is standard definition of Laplace. Call it as 2. Now observe these two. Okay, if I, we have to find out value of, that is our question. If I is our original integration and we know this. Okay, now observe these two. If we have to find out this integration, what we have to find? Laplace transform of f t. Okay, if RHS are same, then LHS must be same. That's why I means we have to find out Laplace transform of which function? F t. What is f t means? The function which is attached to exponential. What is the function attached to this exponential? Sin t. That means value of this integration is nothing but Laplace of sin t. And what is s value? If you observe this, minus is there, t is there, between minus and t, minus sign and t 2 is there. That's why value of s becomes 2. In short, if minus 2 is there, take s value 2. If plus 2 is there, take s value minus 2. Okay, opposite of that. That's why comparing 1 and 2, what we get? I, that is our original question, value of I becomes Laplace of sine t. We have to just recognize the function which is attached to exponential only, and we have to just find out that Laplace, which we have already done so many times. Okay, that's why Laplace transform with sine t with s value, you have to write it as bottom of this line. S is equal to value of s is 2. And what is Laplace of sine? We know this is a standard function, 1 upon s square plus 1. Put s value 2 here. What we get? 1 upon 2 square, that is 4, plus 1, that is answer is 1 upon 5. See how easy it becomes easy. Okay, if we apply e raised to ax sin bx formula here, or any u into v rule here, there are so many steps. Okay, but here only 1 2 3 4 last one, in 4 step only, using Laplace you can find the value of integration. This is the power of Laplace. Okay, or benefit or application of Laplace, you can say. Okay, now consider similarly next example. 78th example, integration. We have to find the value of integration 0 to infinity t e raised to minus 3t sin t. First two step as it is, let I is equal to this integration, and we know this is the Laplace definition. You must have to write these two steps, and therefore comparing these two, or like just write down from 1 and 2, we get I is equal to, what we have to find? Laplace of exponential. Apart from exponential, what is the function remain in the integrand? T sin t. Okay, that is Laplace of t sin t. What is s value now? 3. Okay, now how to find out Laplace of t sin t? Multiply by t property. It's very easy. Okay, now consider let f of t is equal to sin t, multiply by, I am just solving this. Okay, in detail. Laplace of sin t is 1 upon s square plus 1. Call it as phi of s. Now multiply by t property is nothing but, you have to write here property. Everywhere in example also. In some example maybe I skip that step, but you have to write all the formulas and all these things. Now by this formula, multiply additive property, I will not repeat it again in detail. Minus 1 raised to 1 here. d by ds of sin t Laplace is phi of s 1 upon s square plus 1. 1 upon x derivative is applied here, minus 1 upon x square, that is s square plus 1 bracket square, and multiply by its brackets derivative is 2s. Minus minus gets cancelled, 2s upon s square plus 1 bracket square. This becomes Laplace of t sin t here. Therefore put the value of this in this equation, that is our original question. Therefore from 3 it becomes I is equal to, this is Laplace, s value is 3. Put s is equal to 3 here. Now next step, we get this number, simplify this, we get answer is 3 upon 50. Okay, now next 79th example, integration from 0 to infinity e raised to t sin square t upon t dt. First step as it is, let I is equal to this integration, call it 1. Now let, this is definition of Laplace, call it as 2. Now comparing these two, what we have to find? I is equal to Laplace of now which function? Exponential function, which is function attached to exponential, that is this function, that is sin square t upon t. S is equal to, what is s now? Here positive sign is there, that's why we take s as minus 1. Okay, now we have to just find out this Laplace. We already solved this Laplace so many times. In division by t we have to use here. Okay, before that we have to find Laplace of sin square. Before that we have to put sin square formula. You know all these things. Now I just solve all this thing here. Okay, already we solved this so many times. Okay, this is the answer, you go through that. Earlier also maybe we have solved this. Laplace of sin square t upon t by division by t property is answer for this is, just solve this here, this one. Okay, you solve that as it is. Now what we have to do from our question is equation number 3. Put this value in equation number 3. What we get? Value of I, that is original integration I is equal to this in Laplace here as it is, and s value is put minus 1. Okay, Here 1 by 4 as it is, log minus 1 square is plus 1. Here also minus square is plus 1. 4 plus 1, 5 upon 1 is 5. This is the answer for this integration. Okay. Now next consider 18th example. Integration 0 to infinity. Now onwards I'm just skipping some steps because you have to find out or you are the maybe consider it as homeworks for you. Okay, in between steps, in between Laplace. Now we have to find this integration, e raised to minus t cos square t now is there. Let I is equal to this integration, call it as 1. We know Laplace definition, call it as 2. Therefore comparing 1 and 2, what we have to find? I is equal to Laplace of which function now? The function which is attached to exponential, that is t cos square t. With s value is 1. It's a minus 1 is there, that's why I take opposite plus 1. Now what is this? T into cos square t. This example we have already done before in multiply by t property somewhere. Okay. Or you can solve it. I think it's not there. Okay, you just solve by using multiply by t property. Before that you have to find out cos square t formula, that is 1 plus, here use cos square t formula 1 plus cos double angle upon 2. Okay, put this value in this equation, then find Laplace, then apply multiply by t property, you will get this answer. Okay, and in between solve. This is the homework. Okay, don't skip that, otherwise I will not accept your sections. Okay, assignments. Now this is the answer for this. Now where to put just value, s is equal to 1 here. 2 into 1 minus 6, 1 plus 1 cube, 2 minus 1, 2 minus 6 minus 4 upon 2 cube is 8. There is a minus half is the answer for this question. Okay, now here again same example. Let I is equal to this integration. Here if exponential in any example, if you find out the integration value, an exponential term is given in the denominator, first step take it in the numerator. Okay, because in the denominator we cannot calculate or we cannot compare it. Okay, that's why it becomes opposite, e raised to minus t 2t t square sine 2t. And this is our call it as 1. This is number 2 definition. Now comparing these two, what is I? Laplace of which function now? This function which is attached to exponential, t square sine 2t. With the s value, what is s? Minus 2 is there, that's why plus 2. Again it is homework for you. Calculate this Laplace by using multiply by t property. Okay, just find out earlier examples. If it is there, just copy that here, or if it is not there, just simplify. Okay, this is the answer for this Laplace. Now put s value 2 here. What it becomes? 4 into 3 into 2 square, that is 12 minus 4. Here's 2 to the 4, 4 plus 1, 4, 8, 32 upon, calculate on calci, we get 32 upon 5, 1, 2, or make it in the most simplified form, or keep as it is. Okay, these are some examples of simplifying the integration value. Okay, here some examples are there which are homeworks for you. Okay, we can see. Okay, these are some 1 2 3 4 5 6 examples are there which are based on evaluation of integration. Common question is just evaluate the integration. Okay, evaluate the integration or evaluate this concern thing. Now each example I have given answers to tally. Okay, these are the simple integrations, simple Laplaces. Here you have to find out Laplace of sine square. Here see, in this case where you have to find out first this Laplace, exponential are in subtraction in the numerator. That means it is not this exponential is not belong to the original exponential in the standard definition of Laplace. What we have to do, if your exponential term is not there, that means you have to adjust like this. Exponential, if it is not there, you have to adjust like e raised to 0. That means value of s, what you have to put, 0. Okay, that means in this example you have to find out Laplace of this first by division by d property. Okay, by using earlier method, and put s is equal to 0 in the answer. You get log 2 answer. Okay, in any example like this, here also exponential property, exponential term is not there. That's why you have to first calculate this Laplace by division by t property. Before that you have to use sine formula. Okay, all these things, and put s is equal to 0. You get this answer. I have explained this answer. Now here also take e raised to t on upper side, because it is in denominator. You get e raised to minus t. That means s value 1. And you have to just find out value of this Laplace. Answer is minus 1 by 5. And likewise here also e raised to minus t is there. T cube sine t Laplace. Then put s value 1 here. You get answer 0. Okay, solve these 6 integrations using theories and Laplace definition. Okay.